This will be 2-4 continued. We're going to cover the last two examples, example 4 and example 5. This will go with homework lesson 18. This would be basically systems of equations, and you're going to choose the method that you want to use, whether that be graphing, substitution, or elimination. Looking at this first problem, our two equations here, I would definitely choose substitution. Reason being is when you have one of your equations is already solved for a variable. For instance, we have already solved for y. Y is equivalent to 6x minus 7. I would simply use substitution in the above equation. So I would substitute in for what I know the y value is. So I would come up here, I'd say 4x minus, in for y, we know y is equivalent to 6x minus 7 equals 3. From here, use your distributive property. Remember, there's really a 1 on the outside here, so you're really distributing a negative 1. 4x will drop down. You distribute the negative 1 or the negative sign. This is now negative 6x. Negative into negative 7 would be a positive 7 equals 3. Combine your like terms. 2x minus 6x is negative 2x. Plus 7 equals 3. Need to subtract 7 from both sides. We get negative 2x. 7's cancel out. 3 take away 7 is negative 4. Divide both sides by negative 2 to get x alone. And we find out that x equals 2. Use this value here, substitute back into one of the original equations. So I'm going to use the equation y equals 6x minus 7. I'm going to substitute in for x, which we found out is 2. And we come up with y equals 6 times 2 is 12 minus 7. We find out that y equals 5. So your solution would be 5, or sorry, your solution would be 2, 5. Solution 2, 5 is that point of intersection. We'll move on to example 5 here. Now looking at this example, looking at my two equations, I have the option of graphing, substitution, or elimination in this problem. Since these values are stacked, again, I'd go ahead and use them elimination. If you look here, you're not going to really be able to eliminate right there unless you use some type of multiplication. But here you go, they're 2's. We can eliminate here. Both are negative, so what we'll need to do is multiply one equation by negative 1. You go ahead and use your distributive property. We get negative 8x. Negative 1 into a negative 2 is a positive 2y. And negative 1 into a negative 6 is a positive 6. I'm just going to slide this equation over. You can go ahead after you slide that over and solve. You have negative 8x minus 3x is negative 11x. Here's your elimination taking place. And we have equals 6 plus 27 is 33. Divide both sides by negative 11. And we find out that x is equal to negative 3. Take your value of x here, plug it back into one of your equations above. I'll go ahead and plug it in for 8x minus 2y equals negative 6. Substitute in for x. X we know is negative 3. minus 2y equals negative 6. 8 times negative 3 is negative 24 minus 2y equals negative 6. Add 24 to both sides. And we come up with negative 2y equals positive negative 6 plus 24 is a positive 18. Divide both sides by negative 2. And we find out y equals negative 9. Giving us our solution or point of intersection, negative 3, negative 9. We've covered when we'd probably want to use substitution, when we'd want to use elimination. Substitution is when a variable is already solved, such as example 4. Elimination we'd use when they're stacked upon one another. Graphing, when I would use graphing, is when both equations are in slope-intercept form. When both equations are in slope-intercept form, you can go ahead and use the slope-intercept form method of graphing. This concludes our lesson. You'll continue on